Welcome back. We're in lesson 19. We're going to be talking about some more value word problems, and we're going to use some more subscripted variables. In 19.1, which is our first example problem, we're going to be talking about some money value problems. And we have a guy here. He has a long name, Karamagu. He had 50 nickels. All right. And dimes. So 50 total. We don't know how many nickels. We don't know how many dimes, right? He had 50 nickels and dimes. And their value when you added them all up monetarily was $4. How many of each did he have? So for this, we're going to use subscriptive variables, and we're going to have to write two equations in order to find how many he had. For the first equation I'm going to be writing is all about this first sentence. He had 50 nickels and dimes. We know that the number of nickels plus the number of dimes, that he had 50 total, right? So this is saying that nickels and dimes was 50. That's that sentence right there. Their value was $4. Now we apply their value. So we know that nickels are worth 5 cents. So 5 cents times the number of nickels plus 10 times the number of dimes, because 10 is the value of a dime, that's going to equal $4. And because we're using pennies, we're not using decimals, we're going to write this the way we'd write $4 in pennies. It's 400 pennies. Okay? 5 pennies times the number of nickels plus 10 pennies times the number of dimes equals 400 pennies, or $4. We're just eliminating a decimal by writing it this way. So now we can use elimination or substitution to find out how many of each he had. And I think for this problem, substitution is going to be better because we have two variables that are by themselves. So we can easily swing them one way or the other. And I think the easiest way to do that, or it always seems to be the easiest way for me, is to take the one on the inside and move it over. So this becomes the number of nickels equals 50. And remember, we change sides, we change signs, minus, and I already messed up because I'm human. 50 minus the number of dimes, right? And that makes sense because these two added together is 50. So when you take one away from this side, you have to take that same thing away from the other side. And that's what we did. So now we can substitute wherever we find this variable with this this phrase right here. Okay? So that's what we're going to do on this problem here. We're going to say 5 times, and we're going to substitute in what we know the value of the number of nickels is, and that's 50 minus the number of dimes plus 10 times the number of dimes. Now I want you to notice whenever we do this, we do create a distribution problem, but we also make it to where we only have one of the same type of variable. We have two variables, but they're both the same type. And when you only have one type of variable in a number sentence, then you can solve for it. You can put everything else in relationship to that one variable. So that's what we're going to do now. 5 times 50 is 250 minus 5 times the number of dimes plus 10 times the number of dimes. There's our distribution done. Now we're going to squish everything together, as my son likes to say. So this becomes 5 times the number of dimes, because we took this negative 5 away from the 10. And now we're going to switch sides and switch signs, and that becomes 400 minus 250, and that's going to leave us with 150, right? 150 pennies. Now we just divide both sides by 5, and the number of dimes, 15, or 150 divided by 5 is 30. So if the number of dimes is 30, right, then the number of nickels equals 50 minus 30. So the number of nickels is equal to 20. And that is our answer. Very good. So you can see it's just a process of steps. When you have single variables from your word problem that don't have a coefficient or a constant with them, then you can use substitution to solve that problem pretty easily. Okay, let's move on to 19.2. If you need to write this down, pause it now. I'm fixing to clear the page, or I'm about to. Fixing to is bad grammar. You should say about to. It's a hard habit to break, though. I am 49 this year, and I'm still trying to break that habit. All right, 19.2. This is going to be an elimination problem. Now, keep in mind, you can solve substitution or elimination for either of these, but when you have single variables without a constant, lends itself to substitution a lot quicker than it does elimination. This one is going to be a similar problem, but we're going to just use elimination for the sake of showing that and proving that you can use either one. So in this problem, the fishmonger, so you have a fishmonger, and he sold cod. Cod is a type of fish. It's the kind that they use at Captain D's, if you like Captain D's. The fishmonger sold cod for 6 pence. So he must be in England, because we don't use pence here, we use pennies. So 6 pence each. And he sold mussels. Mussels are like clams. They're just a different type of clam. He sold them for 1 pence each. I would probably give them away because they look like snot. So, I don't eat those or clams or oysters unless I'm, starving to death. And even then, I might just not. All right, if Harriet bought a total of 26 items. So Harriet, this is our lady here, bought 26 items. And she spent 86 pence. How many cod did she buy? Right? So we can get from our first sentence our value for each one, and we can get from our second sentence the total here, the total of items and the total value. So we see we have a value here of 6 pence for well, I didn't list it. Look at that. For cod. He sold cod for 6 pence each. So we know the value of cod is 6, and we know the value of mussels is 1, and we know that the total is 26 items. So we can get our first statement. The number of, let's say, cod plus the number of mussels was 26 of those total. So there's our first statement, and we got that from here. Okay. Now we can apply our value, and we can use that. So 6 pence for the cod and 1 pence for the mussels. So it's going to be 6 times the number of cod plus 1 times the number of mussels. And the value of that was 86. Okay? You guys see how I'm doing that, right? I pulled my 86 from here, and my 6 times C and my 1 times M to get the value, right? So now we're going to use elimination. Even though this is pretty easily lends itself to substitution, we're going to go ahead and use elimination. And the way we're going to do that is, I notice right here we have 1. Well, we know with variables that we have an imaginary 1 in front of each variable that doesn't have a number or a constant in front of it. So we already have a 1 times this and a 1 times this. So all we need to do is multiply this times the negative 1 so we can eliminate something. So we're going to do that now. And then we'll just write that below here. So we have negative 1 times the number of cod minus 1 times the number of mussels equals a negative 26. Now we can draw our line, and we can eliminate, and then we have 5 times the number of cod equals 60. Right? Now we can divide 60 by 5, and we get that the number of cod is 12. Now, what is the question looking for? It says, how many cod did she buy? So did we find the number of cod? Yes, there's 12 cod. Do we even need to go and find out how many mussels? No. We can stop right there because the question is asking about cod. We don't have to substitute this in and find the number of mussels. We don't have to, because this is all the question wants. So that's something that is important if you intend to take the ACT. Always figure out what the question is asking for. That's what you're looking for. Only solve to the point that you sufficiently satisfy the question. Going further is a waste of your time and energy, and it's unnecessary. Especially when time is a commodity. On the ACT, you have a timed test, so time is a commodity. All right, that's our review of those types of questions. So now we're going to move on to the lesson titles it AA means AAA. That's a very abstract idea. I'm going to explain what that means. So pause if you need to. I'm going to clear the page. And let's do 19.3. We're just going to jump into it so I can explain. This is what the lesson is titled. That doesn't mean anything to me. What it is talking about, it's a no choice theorem. And all it means is that when you have, let me draw this triangle here, right, and a similar triangle, you make this a little bit smaller, move it over here. Okay, when you have similar triangles and this one is congruent to this one, and this one, this angle is congruent to this angle, then the third angle has to be congruent to each other. That's all it means. It's a very, abstract and complicated thought process to get to this. If this is congruent to this one and this one is congruent to this one, then the third have to be congruent as well. That's all it's saying. It's kind of unnecessary in my opinion. And the reason for this is because we know that the interior measure of all the angles added together of a triangle is 180 degrees, right? For this triangle as well as for this triangle. So all it's saying is that if this degree of measure and this degree of measure is the same, and this degree of measure and this degree of measure is the same, you add them together, you subtract them from 180, you're going to get the same number here for both triangles. I mean, it's really fairly elementary in that regard. Once you know and once you think logically about your triangles and the value of their angles. So 19.3, that is all that this means right here. Okay, so 19.3 gives us a figure of two congruent angles. And I'm going to see if I can, or it's two congruent triangles. I'm going to see if I can draw it. Okay, that's the figure we're given. And it states that this angle is congruent to this angle. And that this angle, it's a vertical angle, right? Because it's opposite. So it is congruent. We know that it's congruent. It just so happens that because you have a transversal here, that this angle and this angle are the same as well. And that only happens if, let me make sure this is right, this line is parallel, and that looks pretty parallel to this line. So let me make that a little bit bigger. All right, so if this line is parallel to this line, okay, and these are a set of intersecting lines, then the angle here is going to be congruent to the angle here, and we know through the rule of vertical angles that these two are congruent. So we know by definition that the measure of this angle is going to be the measure of this angle. So these are congruent as well. All right, so we can logic that out, not a problem. Now, because they all have congruency in their measure of angles, then they also are going to have a scale factor for their sides, right? So that's all it's saying. It's using this example here to show you that you can find a congruency between these two angles here, which allows you to then say, okay, they're congruent, they're similar triangles, so I can use scale factor to find the missing lengths. So if this is a 4, and this is a 5, and this is a 7, and this is a 6, if this is x and y, oops, sorry, that's supposed to be y. What are their measures? Now keep in mind that we are looking for congruency. So that means that this angle here and the angle that is congruent with it is the same side. So the 5 and the x go together. And then this angle and this angle are congruent. So the 7 and the y go together. And because they are opposite of each other, the 4 and the 6 go together, right? Okay, so now we have to find the scale factor. And because we have all the values for this triangle, we're going to find the scale factor from left to right. So we're going to say 4 times our scale factor from left to right is equal to 6. Now we divide both sides by 4, and our scale factor is going to be 6 over 4, which reduces to 3 over 2. That's our scale factor. So now all we have to do is multiply each side to find the scale factor. And because 5 goes with x, because you have this congruent and this congruent on the same line, we say 5 times the scale factor of 3 over 2. That's going to equal x. So 5 times 3 is 15. Remember, we put that over 1. So 15 over 2 is equal to x. And that's going to be 7.5, right? So x is 7.5 of something, whatever the dimensions are. And we do the same thing for y. We say 7 times our scale factor of 3 over 2 equals y. And we put that over 1, we multiply, that's 21 over 2. So that's going to be 10.5. So y equals 10.5. It could be inches, it could be whatever. But that's how you solve for that. You just identify which sides go together. So this side is going to be matched up with this side because of which angle is attached to this line. All right, so that's what you're doing. You know that 5 goes with x because you have the 1 tick mark here and the 1 tick mark here. They're congruent angles. And 7 goes with y because on this line for 7, you have the 3 tick marks and the 2 tick marks. And on the y line, you have the 2 tick marks and 3 tick marks. They're congruent. So that's how you match up the sides correctly. 5 would not go with y because you have the 1 and the 2, and y has the 2 and the 3. So those are not the congruent sides. That's how you have to look at it. And we know that the 4 and the 6 are congruent because you have the 1 and the 3 together and the 1 and the 3 together. Okay? You have to match them up. All right, and that is all we have for lesson 19. And I'll see you in lesson 20.